All right. So, very similar to what we did in class for this lesson. We're going to do three things. If it's not already in conditional form, rewrite it. Underline the hypothesis and circle the conclusion. Write the converse, which just means, remember, whoopsie, doesn't mean whoopsie. It means just switch the two parts, the hypothesis and the conclusion. Decide if that's true, and if false, write a counterexample. So, if you get good grades, then you'll get into a good college. We have if, we have then, all right? So, we're good to go. We don't have to rewrite it. So, A is done. B, underline the hypothesis. You get good grades. Circle the conclusion. You'll get into a good college. Now, the converse. Just switch these. If, notice I didn't underline if. That way I'm just switching this part. If you get into a good college, then you got good grades. So, is that true? You got into college, you must have gotten good grades. I'm going to say false. Not because it's always false, but not necessarily true. Okay? And so, what could prove that false? Average grades and athletic scholarship or music scholarship or something like that, some talent outside and above your grades. Okay? So maybe you didn't have the best grades in the world, but you had a high, like perfect ACT score. So it shows your potential, your knowledge is there. All right, number 2, all people who are hungry eat food. Well, that is not an if-then statement. So, if you are hungry, and you could say if you're a hungry person or if you're a person who is hungry, whatever. If you are hungry, then you eat food. So I'm just taking that statement and put it into an if-then statement. My second part, underline the hypothesis and circle the conclusion. So underline everything after if, circle everything after then. Now the converse, flip these, switch them. If you eat food, then you are hungry, or were hungry. Again, could be true, but not necessarily, so we're going to say false. Because you could be sad. Some people eat when they're sad or stressed. Not necessarily hungry, or a friend shared food with you. You weren't hungry, but that was a really good-looking pizza, or biscuit, or whatever, or cake. All right, 3, all students who struggle with math come to get help from, well, says Ms. Peepo, one of the other math teachers. Sorry, I didn't change that. So let's make it if then. If you are struggling with math, again, if you want to say if you are a student struggling with math, then you come get help from Ms. Pipo. So, hypothesis, you're struggling with math. Conclusion, you come get help. All right. Now, converse. If you come get help, save space, I'm just going to say if you come get help with math. If you want to say from Ms. Pipo, that's fine. You are struggling. Now, that is false. Partially. Again, all of these could be true. Okay? You're coming to get math because you're struggling. You're eating because you're hungry. But if there's an element or a possibility of false, we say false and then disprove it. So why else might you come get help with math? You know, after school with Ms. Pipo. Your ride doesn't get here. I can write OE, not EO. Hopefully you're getting the idea that there's not one answer here. Okay? But let's say your ride doesn't get here, so you just hang out with Ms. Pipo to work on math. Or maybe you just enjoy working with a teacher. Or maybe your best friend is going and you're just going to get extra help. So there's a lot of ways you can disprove it. And it's very easy to get these right. Just put something that makes sense. Now write your own conditional statement about something you enjoy. If I make this video, then my students will all pass the test. Okay, so if I make this video, hypothesis, my students will all pass the test, is my conclusion. So the converse is, if all my students pass the test, then I made a video. Okay. Well, is that true? That's false. Someone could pass without watching. They just understood it, didn't need the extra help. Okay? Moving on. Remember, hit pause if you need to or go back. Okay, identify each angle pair in relationship. Okay? Complementary. And you can just abbreviate it comp L. Okay? This one, linear pair. Supplementary. This one, vertical angles. Now, the relationship, remember, this is very important. They add to 90. They add to 180. And they are equal, congruent. All right, looking over here, just like on the worksheet we did. Angle 1's 130, sorry, my bad. Angle 1 is 35. So here's angle 1. What is angle 11? Well, those are vertical angles, so also 35 degrees. And we're going to say linear pair. No, we're not. No, we're not. Because they're not. We're going to say vertical angles. Okay? And the relationship is congruent. Number 9, angle 7. Where's that? Angle 7 is right here. It looks like it's 90, but it's not. It's 91. And angle 8, right there. Well, what are those two? Those two are a linear pair. Okay? And remember, they add up to 180 because they form a straight line right here. So since they form a straight line, part plus part equals whole. So x plus 91 equals 180. 180 minus 91 equals 89. And the relationship is they add up to 180. Clean that up. If you use supplementary for the name, I accept that also. Number 10. Angle 15, where's that? It's 72 degrees. What's angle 16? Well, notice we have that special right angle symbol there. So that means they're complementary. And that means they add up to 90. So you can simply do 90 minus 72 and get 18 degrees for 16. Number 11, angle 23, where is that? That's here. And angle 22, well, that's here. What do they form? A straight line, 180 degrees, which means they are a linear pair. They're supplementary. The relationship is they add 280 degrees. So if we just do 180 minus 135, we get 45 degrees for the angle. Right, number 13. Number 13, I'm sorry, let's go to number 12, then we'll do 13. Number 12, angle 9. Where's that? Well, we're going to come up a little bit. Angle 9 is right here. Angle 10 is right here. What do? They form a straight line. So they are supplementary. They are a linear pair. So part plus part equals whole. So 6x plus 1 plus x minus 3 equals 180 because supplementary angles, linear pairs, add up to 180. Now we combine the x's, 7x, combine the numbers, minus 2 equals 180. We're going to add 2 to both sides and get 182. And then we're going to divide by 7. 182 divided by 7 is 26. Now, it said find x and each angle, so that's only part of our answer. We need to plug 26 in here and here. So the measure of angle 9 is 6 times 26 plus 1, 157. And the measure of angle 10 is 26 minus 3, 23 degrees. All that is my answer. x and both angles. And notice they both add up to 180. Okay, moving on to number 13. Number 13 talks about angle 13. I was so confused before, possibly. So angle 13, where's that? That is right here. And angle 20 is right here. Well, what are they? They are vertical angles, which means they're congruent. So we're just going to set them equal to each other. 5x plus 1 equals 46. Subtract 1. 5x equals 45. Divide by 5, and x is 9. That's not my only answer. I had to plug in 9 here, and 20 is easy. So the measure of angle 13 is 9 times 5 is 45, plus 1 is 46. Now it's easy because they're linear pair, they're equal. So if we know this is 46, this has to be 46. So the measure of angle 20 is obviously already 46 degrees. But did say give both, so there you go. And last but not least, angle 15 and 16. Let's find out where they are on the drawing. So angle 15 is right here. Angle 16 is right here. And again, they form a right angle. They're complementary. They add up to 90. So therefore, I'm going to say part plus part equals 90. 6x plus 3 plus 2x plus 7 equals 90. So 6x plus 2x is 8x. 3 plus 7 is 10. Let's subtract 10 from both sides and get 80. And I divide by 8 and I get 10. And it says find each angle. So I got to plug in 10 right here and 10 right here. So I'm going to say the measure of angle 15 is 6 times 10, which is 60, plus 3 is 63 degrees. The measure of angle 16 is 2 times 10, 20, plus 7, 27. And that's it.